Hello, this is Mathematics in a Modern World. Today we are going to tackle the language of relation and functions. So, what is language of relation and functions? In mathematics, the language of relations and functions is used to describe the relationship between elements of set. Relation. A relation between two sets is a collection of ordered pairs containing one object from each set. If the object X from the first set and the object Y is from the second set, then the objects are said to be related if the ordered pair XY is in the relation. To have a clear understanding on the concept of relation, let's have example number 1. Let C equals the set of 2, 3, 4, and D equals the set of 0, 1, and define a relation R from C to D as follows. Given any ordered pair X, Y is an element of C cross D, and the ordered pair X, Y is an element of R, means that X plus Y over 2 is an integer. We have here A. State explicitly which ordered pair are in C cross D and which are in R. B. Is 2 related to 0? Is 3 related to 0? And is 2 related to 1? C. What is the domain and codomain of R? So we have here our A. To answer A, let us first determine C cross D. We have our C is a set of 2, 3, 4, and D the set of 0, 1. Remember that to cross C to D, we have to pair C first with the elements of D. And then we are going to put the ordered pairs in a set. We have here 2, 0, 2, 1, 3, 0, 3, 1, 4, 0, and 4, 1. So this is now our answer to the first question in letter A. And what we are going to do next is to find the ordered pairs which are in R. R means the ordered pair xy that x plus y over 2 is an integer. By the way, for a quick recap, integer includes whole numbers plus their counterparts less than 0 and 0. So let's have 2, 0. Is 2, 0 an element of R? Yes, it is an element of R since 2 plus 0 over 2 equals 1, which is an integer. How about 2, 1? Is it an element of R? No, it's not an element of R because 2 plus 1 over 2 equals 3 halves, which is not an integer. How about 3, 0? Is it an element of R? No, because its result is also 3 halves, which is not an integer. Next is 3, 1. Is it an element of R? Yes, because 2 is an integer. How about 4, 0? Yes, because again, 2 is an integer. And lastly, 4, 1. No, because 5 halves is not an integer. So these are the relations found in x plus y over 2 that are integer. That's it for A. Now let's answer letter B. Is 2 related to 0? Yes, because 2, 0 is part of our relations. How about is 3 related to 0? No, because its result is not an integer. Next is 2 related to 1? No, because 2, 1 is not part of our relations. Now let's proceed to letter C. What is the domain and codomain of R? Our domain is 2, 3, 4, and our codomain is 0, 1. So here we have another example. Let A equals the set of 1, 2, 3, and B equals the set of 2, 4, 6. And let R be the divides relation from A to B. For all ordered pair XY is an element of A cross B, and X related to Y if and only if X divides Y. Draw an arrow diagram for R. Again, we have our A equals the set of 1, 2, 3, and B equals the set of 2, 4, 6. Now let's determine A cross B. Again, to cross A to B, we have to come up with ordered pairs and put them in a set. And it should always be the A that will come first before B. We have 1, 2, 1, 4, 1, 6, 2, 2, 2, 4, 2, 6, 3, 2, 3, 4, and 3, 6. After that, we are going to determine the ordered pair which X divides Y. For our relations R. So is 1, 2 part of our R? Yes, it is because 2 is divisible by 1. Okay, to avoid confusion, X divides Y means that Y is divisible by X, or X is a factor of Y. So let's go to 1 and 4. Yes, it could be 1 and 6, 2, 2 and 2, 2, 4, and 2, 6. Because the Y are divisible by X. How about 3, 2? No, because 2 is not divisible by 3. 3, 4? No. And 3, 6? Yes, because 6 is divisible by 3. This is our arrow diagram. We have A, 1, 2, 3, B, 2, 4, 6, where 1 maps 2, 1 maps 4, 1 maps 6, and 2 maps 2, 2 maps 4, 2 maps 6, and 3 maps 6. The relation here is X divides Y. So that's it for our example number 2. Let's proceed now to function. In mathematics, a function from a set X to a set Y assigns to each element of X exactly one element of Y. The set X is called the domain of the function, and the set Y is called the codomain of the function. We have here the two properties of function. The first property. Every element of A is the first element of an ordered pair of F. This means that all elements of A should have a pair in B. It's fine if an element of B doesn't have a pair as long as all the elements of A have a pair. The second property. No two distinct ordered pairs in F have the same first element. So, no first element will be repeated. Next, let's define notation. If A and B are sets and F is a function from A to B, then, given any element X in A, the unique element in B that is related to X by F is denoted Fx, which is read f of x. Let's have our example A. We have let A equals the set of 1, 4, 9, and B equals 1, 2, 3. Which of the relations x, y, and z defined below are functions from A to B? We have here A. X equals for all ordered pair xy is an element of A cross B, and ordered pair xy is an element of X that X equals Y squared. So we're also going to use an arrow diagram. We have our A 1, 4, 9 and B 1, 2, 3. The relation here is x equals y squared. So 1 maps to 1, 4 maps to 2 because 2 squared equals 4, and 9 maps to 3 because 3 squared equals 9. So let's see if this is a function. So here we are going to base on the two properties of function. Keep in mind that it is really important to remember the two properties of function by heart. Let's check if it satisfies the first property. Every element of A is the first element of an ordered pair. So check for the first property. How about the second property? No two distinct ordered pairs have the same first element. So let's check. Also check for the second property. So this is a function because it satisfies both properties of a function. Now let's try B. Y equals the set of 1, 1, 4, 1, and 9, 3. We have our A, 1, 4, 9, and B, 1, 2, 3, where 1 maps 1, 4 maps 1, 9 maps 3. Let's check if this is a function. For the first property, every element of A is the first element of an ordered pair. So check because all the elements in A have a pair. How about the second property? No two distinct ordered pairs have the same first element. Also check because no first element are the same. So this is also a function because it satisfied both properties. Now we're down to letter C, where Z equals the set of 1, 1, 4, 2, 4, 3, and 9, 3. We have our A, 1, 4, 9, B, 1, 2, 3, where 1 maps 1, 4 maps 2, 4 maps 3, and 9 maps 3. Let's see if it will satisfy the two properties. So check for the first property because all the elements of A have a pair. How about the second property? It doesn't satisfy the second property because we have here ordered pairs with the same first element. That's it for example A. We were able to gain here that not all relations are functions, but all functions are relations. Okay, we have more examples here. Let A equals MARC and B equals LAWRENCE, where R equals the set of ML, AA, RW, RR, RE, CN, CC, CE. We have here in our arrow diagram M to L, A to A, R to W, R to R, R to E, C to N, C to C, and C to E. So is this a function? No, it's not a function because remember the two properties? The first element should be unique. No distinct ordered pairs have the same first element. Another example, we have our A MHEL and B JHON, where our R equals the set of MOHOEJLO. Okay, how about this one? Is this a function? Yes, because it satisfies both of the two properties of a function. This is an example of many-to-one function. Now we are down to our last example. We have let A equals Joseph and B equals Saligan. And our relation R equals SSOASLEIPGHA. In our arrow diagram, we have J to S, O to A, S to L, E to I, P to G, H to A. Let's see if it satisfies both properties of a function. So we can see here that every element of A has a pair. So check for the first property. How about the second property? Also check for the second property, right? Because all of the first elements are unique. That's all of it. Thank you for... And by the way, I encourage you to try this sample problem here. Let A equals the set of 3, 5, 7 and B equals the set of 4, 6. And relation U and V from A to B as follows for all ordered pair XY is an element of A cross B. And all ordered pair XY is an element of U means that X minus Y is greater than 3. And ordered pair XY is an element of V means that X minus 1 equals Y over 3. Again, thank you for listening and watching. I hope you have learned something. And please don't forget to like and subscribe.